All right, so let's talk about something that sounds a bit like a contradiction, right? A clean coal power plant. Today, we're going to dig into a fascinating engineering challenge by using a brand new plant in Kazakhstan as our blueprint, just to see how modern tech tackles this massive task.
So let's just start with the biggest question of all. How do you even begin to clean the smoke from a giant power plant that's burning coal? I mean, really think about that. It is a huge, huge challenge, but it's one that modern engineering has some pretty impressive answers for.
And for those answers, you know what? We've got the perfect masterclass to look at. This new project in Kazakhstan is being built to be one of the cleanest coal plants in its entire region, which makes it an amazing case study. So let's dive in and see what that really means in practice.
Okay, first things first. We're not talking about just making things a little bit better. The goal here is to meet a whole new, incredibly high standard for what clean even means for a coal plant. And these numbers right here, they define the entire challenge. These aren't just wishful thinking. They are hardcore emission limits, basically on par with the super strict standards you'd find in the European Union. We're talking milligrams per cubic meter. That's like trying to find a few grains of sand in a giant box. Hitting these kinds of targets for dust, sulfur, and nitrogen is a really serious engineering puzzle.
So to really understand how they pull this off, we're going to go on a little journey. We're going to follow a single, tiny particle of flue gas all the way from the moment it leaves the incredibly hot boiler until it's released, all clean, from the top of the chimney.
And here is our roadmap. Our little gas particle is about to go through a gauntlet. It's going to get filtered, scrubbed, pushed by massive fans, and even reheated before it ever sees the sky. Every single one of these steps is absolutely critical. So let's start at the beginning.
All right, first challenge, dust. When you burn coal, you get a ton of this super fine powder called fly ash. The very first big job is to catch all of it before it can go anywhere.
So, the engineers basically have two main options on the table. First, there's the electrostatic precipitator, or ESP. Think of it like using static cling on a massive industrial scale to literally zap the ash right out of the air. It's a total workhorse, super reliable. Then you have the fabric filter. This thing is basically a ginormous, high-tech vacuum cleaner with thousands of special bags. It's even more efficient and can get you ready for even stricter rules in the future. So yeah, it's that classic engineering trade-off. Do you go with the tried and true or the newer, higher performance model?
Okay, dust is handled, but our gas particle isn't out of the woods yet. Next up, we have to tackle the sulfur dioxide. You know, the stuff that contributes to acid rain. And the tech they use for this is, well, it's a mouthful. Wet flue gas desulfurization. But honestly, the concept is really simple. Just picture a giant industrial shower. Seriously, the dirty gas flows up, and a spray of crushed limestone and water rains down on it, and it just washes the sulfur dioxide right out of the gas.
And does this shower work? Oh yeah, the numbers don't lie. The gas can come in with as much as 1,800 milligrams of sulfur, but it leaves with less than 75. That's a removal efficiency of up to 99%. I mean, that is just a staggering reduction.
Okay, so our little gas particle is now almost squeaky clean. The dust is gone, the sulfur is gone, but it's not quite ready to go. It needs one final push to make it to the sky.
This is a three-part finale. First, you need some seriously powerful booster fans just to muscle the gas through all of that cleaning equipment. Second, a special heater warms the gas back up. Why? Well, that protects the chimney from corrosion, and it also cuts down on that big white steam plume you sometimes see. And you might be asking, hey, what about the nitrogen oxides? That's the really clever part. That's handled way back at the beginning with specially designed burners that prevent most of it from even forming in the first place.
So what's the catch? Well, all this cleaning isn't free. It takes a ton of energy to run all this equipment. In fact, as you can see here, up to 6% of the total power the plant generates is used right there, on site, just to run the environmental systems. It's a significant slice of the pie. That's literally the price of clean air.
But wait, there's more. Because it's not enough to just clean the air. A truly modern plant has to think about every single form of waste. And that brings us to water.
The ultimate goal here is something called zero liquid discharge, and it means exactly what it sounds like. Absolutely no industrial wastewater leaves the plant site. Everything, and I mean everything, is captured, treated, and then reused.
And this is how they do it. First, they collect all the wastewater and treat it with chemicals that make all the gunk clump together so it can be filtered out. The water that's left goes through some very advanced purification, like reverse osmosis, to make it clean enough to use again. And that final super concentrated bit of brine that's left over, they just evaporate the water, leaving behind nothing but dry solid salts that can be disposed of safely. Nothing is wasted.
So, when you step back and look at the whole system, the high-efficiency dust collectors, the sulfur scrubbers, the clever NOx controls, and that zero-waste water system, what you really get is the blueprint for a 21st century coal plant.
The result of all this incredible engineering is, to quote the project itself, the creation of one of the cleanest coal-based CHP plants in the region. This is not your grandfather's coal plant. It's a completely different kind of machine.
And all of this leaves us with a pretty big question to chew on, doesn't it? We've just walked through what's possible with the technology we have today, but as that tech keeps getting better and better, it really makes you wonder, how are we going to define clean energy 10 or even 20 years from now?